Thank you so much. Actually, one of the things I just want to put out there right now is how much I love meetups. I mean, because one of my, I think if there's one lesson I've learned over the last 5 years that can be boiled down to this statement: you're only as smart as the average of the top 5 people you associate with, right? And so, to be in a community where you get to hang out with the likes of Mike McGarr, right? And is Paul Duvall here? He was the author of the other great continuous book called Continuous Integration. I mean, it literally is like, I wish I had read these books 10 years ago, right? Because it would have made a material difference and changed the trajectory of my life. But what I want to share with you right now is the 14-year journey I've been on, which is started in 1999 when I started keeping a list of organizations that we call geniuses of people with great kung fu. So these are organizations that talk differently, acted differently, but most importantly, they had profoundly different results than your typical IT organization. They had great project due date performance. They had great reliability, availability, and stability. They had a great security and a great posture compliance. And so I got an opportunity to work with the Software Engineering Institute at Carnegie Mellon University, the Institute of Internal Auditors, and our goal was really to capture and codify how did these organizations become great. And so I want to share with you kind of the first aha moment that we had. Back in 1999, when we looked at where the high performers were coming from, what we noticed is they came from one of 3 professions. They were either a non-commissioned officer in the military, a chemical engineer, or they were an auditor, right? And not just any green eye-shade, bean counting CPA, they were an IT auditor, right? So for all you scientists in the crowd, can you hypothesize what these 3 professions have in common? Non-commissioned officer in the military, chemical engineer, and auditor. Yeah? Discipline. Yes, got it in one, right? Any other words come to mind? Process. Other words? Any other words? System thinking. Yeah, the words that I think kind of that we settled upon after 3 years that you got in one shot, right? Rigor and discipline, right? So why would that be? Non-commissioned officers, they give live ammunition to 18-year-olds. What I've learned in my journey is that in restaurant operations, they don't even give knives to 18-year-olds because you combine 18-year-olds, knives, and raw carrots. The accident rate is so high that the insurance companies get involved and take the knives away. Chemical engineers, they have long, elaborate recipes that if you missequence 2 steps, endothermic can become exothermic and people lose fingers. At Purdue University, I was an engineering student for a couple of years, and we had a joke. How can you tell if a professor in the engineering department was a nuclear engineer? Count their fingers, right? If they don't have all 10, they're a nukie. And then auditors, they haven't met a control or a checklist or a process they haven't loved, right? So, what we found after benchmarking over 1,300 organizations, trying to link controls and behaviors with performance, right? What we found was that, rigor and discipline actually, could predict about 60% of the performance. So, that's not what we actually, was the research that led us to create this nonprofit called the IT Process Institute. Our goal is to capture and codify how these organizations made their good to great transformation. And that's what went into the VisibleOps handbook. By the way, is there a way to get the feedback to go down, or should we just keep going? All right. Yeah, so the biggest surprise in this journey for me was that it took me straight into the heart of the DevOps movement. And just to give you some background on me, my first job out of high school was a file system QA tester for the Sun OS kernel. And I was one of the idiots who actually was, when we were at Sun, I was so proud that I became one of the first people to use the Jupyter System 5 Release 4 Solaris build. It turns out I was the only person dumb enough, right, to actually use Solaris when Sun OS is so much better. I got my introduction to security when I was at Purdue University, but I consider system administration and operations my primary area of passion. I was the founder of a company called Tripwire, so it was about a $100 million a year enterprise security software company. So I ran the engineering department for several years. I've been a build engineer. I've been a developer by training. So, and I'm probably the worst DBA on the planet. Never let me touch a database. So, what I want to share with you sort of this downward spiral that we started seeing in every organization that I think, in my mind, sort of set me up to become, one of the most avid DevOps proponents. So let me share with you why I think the DevOps is urgent and important, and a logical continuation of what the Agile movement started 11 years ago. So the story can almost be told always in 2 acts. The first act always begins with IT operations. And so how many people here have done time in operations as a sysadmin? Yes, okay, great. So for those of you who, you probably know the feeling of having to keep services running that run on crappy, fragile infrastructure. Right, we call it fragile because every time you touch it, it blows up, falls over, and causes a huge unplanned outage, right, and a huge episode of unplanned work. right? And so the tragedy about fragile artifacts or fragile code, right, is that it typically runs the most critical business operations for the organization, or it underpins the most critical business initiative for the company. And so when those things are fragile, right, and often no one knows how to build a new one, right, so it's very bad when they fall over. Bad things happen because it runs critical business operations, critical business initiatives run on them. So when that happens over and over again, the organization becomes unable to hit the promises that it makes to the market, right, and to the outside world. So sometimes that's a feature that we promise to customers. Sometimes it's earnings per share promises that we make to Wall Street. Sometimes it's promises about strategy and execution that we make to analysts. And so when this happens, speaking as a married person, I know, right, that part of human nature is when we miss promises, we tend to compensate by making bigger, more audacious promises, right, that we have even less of a likelihood or probability of hitting, right? And so I think that's human nature. The problem is who's making these promises. It's these people, the product managers, often art majors, creative writing majors, right? And some of my best friends are creative writing majors. However, right, these are the people who may not have the best idea of what technology can and can't do, right? And so now we enter Act 2, the developers. So in operations, we have a joke, right? Show me a developer who isn't causing an outage, I'll show you one who's on vacation. But speaking to this crowd, right, we're not talking about developers, it's the DBAs. DBAs, right? Actually, this is actually a true story. Someone actually said in operations, right, we found that when all the DBAs went to Oracle World for like a week, they had the fewest number of unplanned incidents, right? And then when they came back, they had the highest number of unplanned incidents because like they had learned all these cool tuning tricks. Anyway, so so as development, we see urgent date-driven projects put into the queue where a commitment has already been made to the outside world, right? Made by the organization. And so two bad things start to happen. One is, as developers, we have to focus only on the features, right? We have to basically crowd out every other non-functional requirement: stability, security, scalability, manageability, and so forth. Secondly, we have to take all the time in the schedule to deliver on the customer promise, right? Leaving no time for the downstream work centers, like testing, capacity testing, security, operations, deployment, right? And so when this happens, we start to cut corners, and then technical debt starts to accrue, downstream, right? And so when I try to visualize technical debt, here's a picture that comes to mind, right? At the completion of every one of these projects, we have one more fragile artifact in production, right? And so this is a downward spiral because now we have one more fragile artifacts become more fragile, right? And we have more of them. But there's actually, and by the way, we call it technical debt for a reason. This eventually turns into this, right? And by the way, this is actually bad for availability, right? So suppose that you have an outage. You even know it's due to a cabling error, right? Which cable is it, right? And it's between the SAN and the database. It's this one, right? Right? But don't jiggle the cable, right? Because we know that a couple of them are loose. So, but there's actually a more insidious downward spiral that actually starts to happen, which is that deployments start taking longer. So, think of a friend who's been associated with an application. It used to take 5 minutes to deploy, starts taking 10 minutes, starts taking an hour, starts taking 3 hours, starts taking a day, starts taking 2 days, right? And so 2 days is about the limit of like, something interesting happens in 2 days. At least those ops guys can finish the deployment over the weekend, right? That's okay. But it starts taking 3 days. Right now, we all have to do heroics in order to finish the deployment without impacting the customer, right? It starts taking a week, starts taking 2 weeks. There's actually an organization on the West Coast that I had the honor of being able to observe. They had it was about a $6 billion a year company. It was a 1,300-step deployment process, 6 weeks to deploy. Right, and so and it had the most horrendous deployment outcomes you could imagine. In fact, the disaster scene in the Phoenix project is actually based on that. Right, so when that happens, no one is achieving their goals. Right, this is where now you have the sort of decade-plus tribal warfare between operations and development. So here's the developer who hits commit code. Right, they high-five each other in the parking lot, go to the bar, have a couple tequila shots. I shouldn't say tequila based on what happened a couple weeks ago. Anyways, they have a couple tequila shots, right? Not realizing they set the entire data center on fire, and now they had to call those developers back in, right, to restore service and figure out what went wrong. And at this point, no one's achieving their goals, right? Features are not getting to market. Deployments are taking longer. The number of 7-1 incidents that keep going up, right? And operations becomes even more mired in firefighting. How many people here have a friend that could resonate with at least some elements of the story? right? Yes. You're not alone, right? You're not, in fact, this happens everywhere. Oh, there's one more constituency here. Any information security people here? Yes, right. Yes, I'm one of you guys, right? And so, if you think life in operations sucks, try walking in the shoes of InfoSec, right? When you're in InfoSec, basically the buffet table is empty by the time we get to go, right? And so now we're doing the most degrading work there is in IT, which is compliance work. At this point, we're not even making the organization happy. We're just trying to make the auditors happy, right? Just check the box. And instead of making the data and the applications and the organization secure, right? All we're doing is essentially making auditors go away. So this is what I would say leads to a sense of hopelessness and despair, right? So a friend of mine, his name is Josh Corman. He's an information security researcher, and he did a study of burnout in information security, and I would bet these findings apply just as much to IT operations as they do to InfoSec. He found that in InfoSec, the rates of burnout are off the charts. It is higher than first responders, physicians in the emergency room, people doing multiple tours of duty in the military. Right? And I think the reason why IT operations would probably score as high. Oh, by the way, what are the signs of burnout? Fatigue, certainly. Second is cynicism. Right? Like in information security, and I think operations too, kind of cynicism is our core competency. Right? And the third is like illusions of self-efficacy, right? Where you actually think we're actually better than we are. So yeah, so this is a horrible thing. It's like when you feel like we are trapped in a system that preordains failure, where we are powerless to change the outcomes, right? I mean, that's actually not only bad for us, it's bad for the people around us, but it's actually one of the worst things you can do to a fellow human being, right? Which is to deprive them of their ability to actually change or control their outcomes. So, how many doing here so far? Interesting? Thumbs up? Okay. Okay, great. By the way, okay, so this happens everywhere. And by the way, if Paul Duvall were here, and I wish I had my mic many moons ago, because this actually happened to us at Tripwire. Right? I remember distinctly around 2006, we were actually having just tons of problems with getting releases out, right? Because we had every developer working on this on their own branch, and at the end of each release, we scheduled a week to do the feature merge, right? And it never took a week; it would take a month, right? And for a month, we had no working code, right? And it was so painful, we did it less frequently. In other words, we were like, we're not going to do a deploy release once every 9 months. We're going to do a year, right? Next, it was a year and a half, right? And so this is like the worst type of downward spiral. It's a self-reinforcing loop. The worse you get, the worse you get. So why does this happen in every organization? One of the things that I think is so interesting is that this downward spiral happens in every industry vertical. Every company size, large, small, profit, not-for-profit, financial services, retail, higher education. I think it's because it's a part of a side effect of how we're organized, dev and ops, because every IT organization has two valid business needs. We have to respond quickly to urgent business needs, and that means make changes and ship features as quickly as we can, right? So I would say the head of development. And on the other hand, we also have to preserve reliable, stable, secure service for the customer, right? And so would say the head of operations, make no changes ever over my dead body, right? And what I've learned in my journey is that is quickly arranged. Time to market will always trump availability and security, right? So I think that's a fact of life, and it has caused constant struggle and strife. The next question is why every company, right? The first one is because of a side effect of how we're organized. The second one is because I think evidence in the numbers. So the first statistic says 95% of all capital projects have an IT component, right? So, and the second one is that 50% of all capital spending is technology related. So in the Phoenix project, it's a novel about a fictitious company. If we could have made them a gravel manufacturer, we would have, right? Because this whole notion of executives saying we're not Google, we're not Microsoft, IT is not a core competency. I think that is the height of self-delusion, right? Because any company that has any reliance on IT, right? IT is a competency they need. In other words, regardless of what business they think they're in, they're actually an IT company. So I think the visceral proof point of that to me is, whenever the organization says we are here, right, and here's where we need to go, right? Who's in the way? Who's constipating the flow of work, sort of preventing the organization from achieving its dreams and aspirations? It's those IT guys, right? And if you drill into the IT box, right, chances are, especially if you have multiple development streams feeding into one IT group, IT operations group, then it's IT operations, right? IT operations, has become the bottleneck. So in my mind, that explains kind of why, this happens even in companies that aren't, don't think of themselves like a Google or Microsoft. So Act 3 is really, there is a better way. And the reason why I'm so excited about DevOps, continuous delivery, continuous integration is that until very recently, I think by the way so many of us were trained is that, it was impossible to be fast and nimble while being reliable, stable, and secure. Right? And so, I think that, what we are living in is this kind of incredible convergence of not only just continuous delivery, DevOps, lean UX, lean startup, the rampant innovation culture. So I think historians 10 years from now will say something magical and transformative happened around this time, plus or minus, a couple of years. But, I think DevOps will definitely be a piece of it. And, I think we all have our kind of liberation theology, right? Agile certainly has theirs. In DevOps, I think the seminal moment that we point to as a community is this presentation. How many people here have seen the famous Allspaw-Hammond presentation, from 2009? Okay, for those of you who haven't, it's actually on YouTube. I mean, it is still, I think, great. It was a presentation that was given by John Allspaw and Paul Hammond. Who are they? John Allspaw was the head of operations at Flickr. Paul Hammond was the director of engineering at Yahoo. And they gave this presentation at Velocity, which is where organizations like Google, where the unicorns hang out. Google, Twitter, Amazon, and this is where they show off the toughest ops and engineering problems. And so they gave a presentation called "We're doing 10 deploys a day, every day, by dev and ops working together," at Flickr. And so I wasn't there. I was actually there the next year, but by all first-hand accounts, people who were there said they knew that they were in the presence of something magical, right? That, that they knew something special was happening. But if I had been there, I think my reaction would have been like this. It's like, 10 deploys a day? 1, that's impossible, they're lying. 2, even if it were possible, right, why would they want to? What idiot would want to do 10 deploys a day, right? Why would they do that? It's irresponsible, reckless, probably immoral, because everybody knows, right, that you can't, if you want stability, that's not what you're supposed to do. And I believe that now, and anyone who's going to a continuous delivery meetup, right, knows this, is that I think it's actually probably one of the most critical capabilities that any organization need to build. I mean, I wish I had learned this 7 years ago because, I see our own downward spiral, right, happening, and this would have been the right countermeasure. So the Allspaw-Hammond presentation is great, right? They've kind of cast development as operations as two very diametrically different vocations, right? You have Spock, the embodiment of development, that's you guys, right? Or many of you guys. Cerebral gets to sit on the bridge with Captain Kirk, right? Captain Kirk actually asks Spock for advice, actually listens to the advice. Whereas Scotty, the embodiment of operations, is stuck in the basement, right? No one invites Scotty to the meetings, right? And the only time Scotty gets invited to the meetings are when the warp engines are down, step 1 incident, right? And I don't think Scotty ever actually says, "I told you so," right? Because of all the deferred maintenance, we should have replaced the dilithium crystals like 2 years ago, right? But he we'll say, "No, we can't do it," but Captain Kirk says, "Damn it, Scotty, we need warp speed now," and he will deliver. But he still doesn't get invited to the meetings. So. I think that's just kind of a great sort of description of the temperaments of both development and operations. And as information security, right? We are these guys, right? We're the first to get shoved underneath the bus when there's a repeat audit finding. So I think what has made DevOps so attractive to me is this slide, right? He said, Allspaw-Hammond said, what we need are ops people who can think like developers, developers can think like operations people. And in my mind, those are boundary spanners. So the research that we did in studying high performers was all about ops people and security people who, instead of having an adversarial relationship, they would actually work together, knowing that what's good for ops is generally good for security and vice versa, because what they both need are controls. And so I think DevOps is inherently a group of boundary spanners. And so the result is not just a torrid summer of love, but it is, by working together, we're getting results that we have never seen before. We're seeing business outcomes that we never even thought possible 5 years ago. So if there's one lesson I treasure most from my work with the Software Engineering Institute, is that high performers always accelerate away from the herd. The best always get better. And I think that's absolutely happening in the DevOps space as well. So one of the presentation that was given in Velocity 2012 was by a gentleman named John Jenkins from Amazon. And he said, 10 deploys a day? That was pretty good for 2009, but these days we are doing at Amazon 1 deploy every 11 seconds, So that's a mean number of deploys, about 23,000 per day, right? So it could be as small as a content change, could be a release of a new feature behind an A/B test. It could be 20,000 new test environments going up, right? All that counts as a deploy. So, so the best keep getting better. Who's doing DevOps? It's not just the unicorns, right? I mean, certainly it is the unicorns who go to velocity, but it's also every SIC industry vertical that we benchmarked. It's in financial services, it's in the retailers. I should add Macy's up there. It's higher education. So, I think, just really, and by the way, I guess what's interesting to me is that when you see the retailers showing up, by the way I was trained, working with analysts, is usually the retailers where we see they're going to be the last adopters of anything technology related. So when you see the retailers piling on, right, we know we have a genuine movement underway. So I want to share with you just a brief thumbnail of the benchmark results that we gathered last year. I got a call from Puppet Labs last year. They were asking for help to do their survey design for their DevOps state of the DevOps practice. And I was so delighted by this opportunity just because I saw this as a logical continuation of the benchmarking work I had done prior. And so, to show that we truly live in an age of miracles, I mean, to benchmark 1,300 organizations took 4 years and about $1 million. We benchmarked 4,200 organizations in 30 days with, no external help needed, right? So, in my mind, that's amazing. So there are 3 surprises that came out of the study that just blew me away, and I'll share with you the first one right now. The first surprise was how much high performers are outperforming the non-high performing peers. So out of the 4,200 organizations, the high performers clustered. They had they were doing 30 times more frequent deployments with an average lead time that was 8,000 times faster than their peers. In other words, the time required to go from code committed to code successfully running in production was measured in minutes or hours, versus for the non-high performers, it was either weeks, months, or quarters, right? And so I would say kind of from anecdotal evidence, right, for the non-high performers, right, that are in quarters, it's often because even to get a test environment, right, takes 42 weeks. To run the entire manual test suite takes 6 weeks, right? And so if those are the critical parts of a deployment, right, you'll never get to these on-demand type of numbers, minutes or hours. The amazing part is that not only are they deploying more frequently, but they're also getting far better results. They had twice the change success rate, right? And when Murphy hits, right, and a Seb1 incident happens, they can restore service 12 times faster. So in my mind, what was so amazing about this is that this is like the best evidence we've ever had, right, to show that you can be more agile and more reliable at the same time, right? So all the book learning in continuous integration and the continuous delivery books, we're now actually have empirical evidence that that's true. How am I doing here so far? Is this interesting? Okay. For anyone who nodded, could you say why? It's just, I'm sorry? Numbers. Yes, right. It's more than just folklore, right? Any other reasons? Just eye-opening. Eye-opening, yeah. So I mean, the fact is that there is a genuine community here that is on the trajectory of making great things like this happen. So go forth. So the book that probably influenced me the most in my entire professional career is this book right here. I recommend this to everybody. How many people here have read the book, The Goal? A couple of, oh, man, this is great. Yeah, for those of you who haven't read it, there's no book that I recommend more. So this is a book about it's a novel about a plant manager who has to fix his cost and due date issues in 90 days, otherwise they shut the plant down. And it was written in the 1980s, and it changed how a generation of people thought about plant operations. And so I've never worked in a plant. I've certainly never managed a plant, but there was no doubt in my mind that this book was important and urgent. And so for over a decade, our goal was to actually write essentially this book but in the IT context, right? Because as John Willis, one of the DevOps Days founders, said, what manufacturing was in the 1980s, technology is today. Had Goldratt written The Goal today, it would have been about technology. And so, the Phoenix Project is that. So we closely modeled the Phoenix Project after The Goal. In fact, I mean, I studied this book for over a decade, right? And we, I think, mirrored the structure. And among many things that the book has in common, there's a Yoda-like character who kind of speaks in very enigmatic, cryptic ways. And he speaks in the language of the 3 ways. And so the 3 ways are really meant to be the set of principles of which you can derive all of the DevOps patterns from. And for that matter, you should be able to derive all of the continuous integration, continuous delivery patterns from. So the first way is all about flow. So it's a way of flow from left to right as you go in the value stream. And so why Dev and Ops? Because Dev and Ops are what's in between the business and the customer. And why? Well, because whenever the business says, here's where we need to go, right, that gets translated into requirements into development, right, which then has to successfully transition into service, right, in order to create value for the customer. And the goal is to, until it's running successfully for the customer, it's just work in process. So the principles behind the first way include understanding the flow of work, right? So work should go quickly from left to right. It shouldn't be standing still. It shouldn't be waiting in a queue. It shouldn't be bouncing back and forth between dev and ops, between the defect tracking system and the ticketing system. And the goal is always to increase flow. I think in the DevOps community, our favorite metric is like deploys per day, so cycle time. But in the lean community, right, they would say the most important measure is lead time. How long does it take to go from raw materials to go on one end of the plant to go to finished goods on the other, right? That is the most important measure and predictor of success. And so one of our goals in the Phoenix project was to make an isomorphic mapping between plant operations and the IT value stream. Because if we could do that, then we could leverage almost 100 years of the body of knowledge, whether it's Six Sigma or the lean thinking tools or the theory of constraints, to apply to dev and ops. And we can never achieve fast flow if we are consciously passing defects downstream. And if we can actually get beyond sort of the classic development measures of how many features can we ship, or the QA measures of like what's our find fix ratio, or availability, or the operations measures of how do we get 100% reliability and availability, right? That's what Deming would say we'll have achieved profound appreciation of the system. So let's go to some concrete patterns that we can derive from the first way. So let's go to lead time. So think of a friend, right, in an application, and how many people here, raise your hand if for that friend, the lead time from code commit to successfully running in production is measured in minutes, hours, days, weeks, months, quarters, right? Yeah, I have a friend like that, right? So, I think what we found in the benchmarking, I think that's actually a little bit better than our 4,200 respondents did. The mean was somewhere between months and quarters. And I think that the proof point of like how you get from quarters down to months, down to weeks, down to days, to better if needed, right, is ask how much of that time is actually spent in queue versus in run. Right, so in manufacturing, the run time is if the drill press is running, or the operator is typing in the commands, or the operation is we're just waiting for the operation to complete, right, or the script is running, right. Queue time is like we're stuck in the ticketing system, or the task is stuck in someone's email box, or we're waiting for the meeting to assemble. Actually, a friend of mine, he's a head of enterprise architecture at a large retailer. And someone on his team made the observation. We polled the developers and we wanted to find out how much of the time was actually spent coding versus trying to convince all the architecture committees and all the other functional component owners, right, to allow the change to go through. He said it was about 1 to 20. So 20 times more time trying to convince people to make, that it was okay to make a change, right? And so this gets worse and worse and worse. So the consequence of when you have long lead times, right, is not just a lot of time elapsed. It actually there's I think a direct proportional linear relationship between batch size and lead time and the quality of the deployment, right? And so whenever in the Phoenix project, there's a specific scene when the evil VP of marketing says we got to ship Phoenix next week, of which then the operations people just freak out and say, what? You can't deploy that. That's not even designed to run. You can't even run it on your workstation. How can you possibly run this in a mission critical production environment? So it's not just a sense of betrayal. You repeat this over a couple of years, right? And that doesn't just create sort of mistrust between dev and ops. It also leads to catastrophic outcomes. I think if you were to look at the most spectacular failures, we believe one of the root causes for that is that it was the first time that the code was actually married to the environment In other words, the first time that the code got integrated with, with anything even resembling the production environment was during the release event, right? So the countermeasure to that is that operations must be accountable and be capable of delivering environments available on demand, right? So the days of tests, waiting 42 weeks for a test environment, right? That has to come to an end. There should be a single, click to be able to get a dev, test, or production environment for anyone who wants one. And they should all be coming from the same build mechanism, right? So this is like one of the prerequisites for continuous delivery. And I sure hope, yeah. And by the way, just to share with you some of my experience, I remember at Tripwire, we were an agile shop, but I actually was very uncomfortable with this because I kind of viewed agile as almost morally wrong. But because in so many enterprise organizations that were our customers, like when the developers went agile, it was like this excuse to ship crappier code more frequently than ever. And I would see the downstream results of this, right? Suddenly the amount of technical debt went through the roof. But now with a little more sort of time, I've come to realize that agile, so many of those agile practices are absolutely right on, right? Because what they nailed was large batch sizes kill, right? Nothing, whether it's in manufacturing or development or operations, our goal is to shrink batch sizes as much as we can. The theoretical ideal in manufacturing is single piece flow, right? Like an assembly line. So if there's one thing that I would love, if I could wave a magic wand, the one change I would make in the agile practice is just a small wording change. The whole notion at the end of every sprint interval, having a shippable product, right on, but that's not sufficient. At the end of each sprint interval, we must have not only working and shippable code, but it must be demonstrated in an environment that matches the production environment, right? And so if we do that, then suddenly, right, by the time we get to the big release at the end, we'll have married the code and the environment together hundreds or maybe even thousands of times. And then suddenly, right, we don't have this need to have this learned behavior that the big release is going to hurt, right? Because we're taking deployment risk off the table by doing this. How am I doing? Yes? Okay. Another pattern that comes from this, right, is the need to decouple features from releases. Decouple deployment from releases. So just show you how dumb I am, right? I've been studying the DevOps patterns for about 4 years. I realized earlier this year that I was constantly conflating deployments and releases. In other words, when I heard the Allspaw Hammond talk, I was actually hearing they're doing 10 releases per day. I'm like, wow, that is really great. And I was a little bit puzzled, I'll admit, of like 23,000 per day. I'm like, wow, how do they have that many features to ship? So, in my mind, right, the big aha moment was like, oh, the Facebook chat feature that was shipped in 2008, each day, right, they were deploying, each developer was checking into trunk at least daily, right, and that was going all the way into production in a disabled state. But there was still one marketing release event. So like Desert Shield, right? Every day, 1,000+ men and materials were being deployed into the staging environment, but there was one marketing release event. So I think by the way, and the coolest part about the Facebook chat story is like not only did they, slowly migrate kind of incremental chunks into production, is how they use that time. For that year, in the Facebook browser client, the browser sessions were actually sending fake chat messages to the Facebook servers, right? So they actually had 1 year of experience of testing the chat messages under load, right? And so that's amazing, right? So by the time they actually deployed by turning on a configuration flag, right, they had a tremendous amount of confidence that the feature was actually going to function as designed. It's like, oh, what a game changer. And I think anyone who's listened to Paul Duvall or Jez Humble talk, that one of the greatest things about this is that this can change the lives of operations. No longer do we have to fear deployments, but we don't have to do them at midnight on Friday anymore, right? We can do them in the middle of the day, right? If we can, bring down the batch size of change. So in my journey, I think there's a couple of patterns that I think are so predictable now in terms of like what kind of the constraint becomes in terms of going from one deploy every year down to deploying on demand. In general, I think the constraint typically always begins in environment creation, right? So whenever we are waiting, 42 weeks for an environment, right? That's pretty typical, especially, I think as a side effect of how ops and dev have worked together in the past. And by the way, what I love about this is that the survival mechanism kicks in. Everyone has compensating behaviors for this. What I found is like when environments take 42 weeks to get, there becomes a black market for environments. Like suddenly you have like Corporal Klinger from MASH saying, hey, you need an environment? I know someone who has an environment, that will work just fine. And so now suddenly people are testing on environments that are like a year old, right? And at that point, when the testing on environments, they don't actually match production, it actually brings into doubt whether the test is actually achieving the test objectives. And then after that, it typically becomes a code deployment process. Like the 1300 deployment, step deployment, right? That became the constraint. After that, it's usually test setup and run, right? I think the classic bottleneck is, we have a deterministic deployment process, but testing still takes 2 weeks to set up and 4 weeks to execute. And so when that happens and we have to deploy urgently, then we just skip testing, right? And we all know what happens when you skip testing, right? And then once we can get automated testing going and continue that integrated into the deployment pipeline, then it becomes I think the architecture, right? How do we get away from this pattern where every time we want to touch something, right, we have to touch 15 other things, right? And so you can't have high deploy rates if things are that tightly coupled. And then after that, the constraint typically moves to development and product management, or as the lean UX guys would say, how fast can we come up with viable business hypotheses that are worth spending our time on, right? Because we don't want to waste our customers' time, and we don't want to waste developers' time, and let alone operations time. So I mentioned there were 3 surprises that came out of the benchmarking study. One was, the extent to which high performers are outperforming their non-high performing peers. The second surprise was there were 2 behaviors that were present in every high performer and absent in every non-high performer. So the 2 predictors, or I guess they're really correlated, but let's call them predictors, does the organization have all their production artifacts checked into version control? And I loved your talk at in Vegas, right? You don't have to put them all into Git. As long as they're labeled, and tagged, right? That's also, I think, fulfills the spirit and intent of this. And ideally, right, everything should live in the same repository as where the developers are living, right? And 2 is there an automated code deployment process which includes creating an environment available on demand? So, literally, if you answered yes to both of these questions, there's a 999 out of 1,000 chance that you're a high performer. Right? And if you answered no to either of them, you have a 1 in 1,000 chance of being a high performer. So, by the way, any questions, comments, concerns, objections on this? They say the goal of science is to explain observable phenomena, confirm deeply held intuitions, and reveal surprising insights. In my mind, this benchmark achieved that. I'm like, yeah, that makes total sense, right? Hopefully it does the same for you as well. How am I doing? Thumbs up? Yeah, great, thanks. So the outcomes of putting the first way into place are creating a single repository that are shared by development and operations. And I used to be a person, trained as an ITIL person. I used to poo-poo technology, and yet I've been always surprised by, wow, when you have developers and operations actually sharing the same tool chain, magical things happen, right? Because there's nothing that builds trust better than actually having visibility into what everyone on the value stream is doing. We now created determinism in the release process, right? We have actually documented the entire deployment process and ideally automated it. We have consistent dev, test, and production environments, all synchronized, built properly, and identical long before the big deployment actually begins. We have now the basis of a continuous delivery pipeline that can be relied upon for not only code commits, but also production commits. We're starting to free ourselves from this learned behavior that deployments hurt. And this is what actually decreases lead time. So one of there are a bunch of AOL folks here. I cannot tell you how much I owe the AOL folks. There was a specific set of meetings that we had with the ops team and a gentleman named Eric Passmore. He was the SVP of Global Engineering at AOL. Does anyone know Eric Passmore? Yeah, a couple of you? Right, I mean, here's my interpretation. He was mostly known as that bleep, bleep, bleep Eric Passmore, right? Because as the head of development, he had like 1,300 developers working for him. He had a reputation of like killing every operations improvement project, before you didn't even have to finish your idea before he said no, right? But there was an aha moment that he had that I'll never forget. I mean, essentially he said, when he realized it took 9 months for the ops team to image the production kernels from 2.4 to 2.6, he said, oh my gosh, right, that was essentially like a code freeze for development for 9 months. You know, the code was ready, but the customers couldn't use it because we need that multi-threading support. He said, that's not an ops problem. That's not even a dev problem. That's like this business problem. And he single-handedly drove, you know, a group of projects that, you know, he became like, he went from that Eric Passmore to, oh my gosh, that Eric Passmore. He became like this, the biggest advocate for IT operations. And one of the things I learned from him was that small changes in the deployment process can result in like wildly improved outcomes. So for the AOL.com homepage, just by doing one thing, the lead time went from 6 hours down to 45 minutes. So in the old days, what they did was, you know, people would put the WAR files into a network share and probably open up a ticket for ops to deploy. And so ops would look at this and, you know, have to do the archaeology, pick through the poo for the peanuts and figure out like how to deploy this, right, with no documentation. And so essentially QA took it over, right, and said instead of putting WAR files there, we're going to put deployable RPM files. And just by doing that, right, shifting the responsibility, deployment times went down from 6 hours to 45 minutes. So the big aha lesson for me was, you know, it doesn't have to be this big mega project. It doesn't have to be this, you know, huge project involving millions of dollars. It can be just even small things that result in great improved outcomes. And when you start increasing, you know, improving the lead time, you know, that's what leads to the improvement of cycle time, you know, where you can get higher deployment rates. Any questions on first way? Okay, second way. So the first way is all about left-to-right flow of work, which is in many ways, right, so much of continuous integration, continuous delivery, you know, is a manifestation of the first way. The second way is the reciprocals. How do we take the learnings that we learn, you know, in every outage or security breach and feed that into the very beginning of the pipeline so that we can actually prevent it from happening again in the future? And if we can't prevent it, how do we at least enable faster detection and recovery? So the platitudes of, or the principles, you know, behind the second way are, how do we respond to the needs of all customers? And I think, you know, as a community, we're very good at understanding who the external customer is, you know, the person at home or the person behind the browser, in our business, whatever. But according to the lean thinking, right, the most important customer is the internal customer, as measured by, as defined by the next downstream step, the next downstream work center. And so, you know, I think the best embodiment of this is the designing for manufacturing, where our goal should always be to optimize for the person who receives our work. The second principle is shortening and amplifying all feedback loops. So I think the best manifestation of this is the Toyota andon cord. So I have some pictures of like myself at the University of Michigan getting trained in the Toyota Kata. And, you know, it's really true. In every Toyota plant, there's actually above every work center is a cord that everyone is expected to pull if something goes wrong. If the parts aren't there, right, on the input side, or if the parts are defective, or even if an operation takes longer than expected, something takes 50 seconds versus 20 seconds, you pull the cord and trucks stop coming out the other end. Can anyone guess how many times in a typical plant the andon cord is pulled in a typical day? Order of magnitude? Tens, higher. Hundreds, right? Thousands is actually 3,500 times a day in the Alabama plant, right? So the question I think is why, right? Why would they stop production 3,500 times a day? And I think it's because they have learned through decades of experience that it is better to stop production and swarm the problem than it is to allow the problem to go downstream where technical debt will accrue, right? And so obviously continuous integration, continuous delivery depend upon, you know, stopping the line. If someone checks in code that breaks the unit test, right, we don't allow more code commits to go in, right? So the trick is now how do we extend that all the way into production? And once we do this, that's creating quality at the source, and that's putting kind of the body and knowledge and capabilities where we need it. So in the DevOps value stream, I think one of the best kind of statements of this came from a gentleman named Patrick Lightbody. He was the CEO of a company, the founder of a company called BrowserMob that was acquired by Neustar. He said, we found that when we woke up developers at 2 a.m., defects got fixed faster than ever, right? I love this quote. So, I mean, obviously the goal here is not to randomly wake up developers, right, maliciously because we don't like them. It's because, you know, I think what this is saying is that whenever we have shared pain, right, this helps significantly with the achievement of shared goals, right? So when developers are put on pager rotation, right, they see the downstream effects of decisions made upstream. And, you know, I think one of the, if you look at the DevOps patterns, unicorns or horses, right? One of the hallmarks is that, you know, developers and dev management are on pager duty, right? Because, you know, dev knows that it's not about how many features you can ship, is it it's about making sure that it's running reliably in production without causing constant Sev 1 escalations. So one of the best examples of this pattern in practice is at Google. This is a gentleman named Tom Limoncelli. And he was actually describing the practices and processes at Google. And so one of the big surprises to me was that they have this policy that says any business application, any application must be self-managed by developers for 6 months before it even becomes eligible to be managed by operations. And so, the question is why, right? I think it's because even at Google, in fact, I know now after talking to Tom, is that even at Google, the scarcest talent they have, and this is at Google, where they can hire anybody on the planet, right, is the SREs, the site reliability engineers, the Uber system administrators, the people who can automate deployments, right? These SREs are some of the scarcest talent they have, and so the worst thing that we can do is actually squander their time, with fragile, crappy code. So they have this thing called not only the self-run, self-managed for 6 months. They have this thing called the HRR, the handoff readiness review, right? And so that's like a production checklist. But look at the kind of the qualitative attributes they're looking for. Show me your pager alert frequencies. Show me your maturity of monitoring and your coverage. Show me your system architecture. In other words, can this eventually sustain high deployment rates? Show me your release process, your defect counts, and then there's this notion of production hygiene. Show me that you have the habits that would make someone even want to cohabitate with you, right? And if you don't, right, then you're just not ready. So I think what is really fascinating to me is what happens when code goes fragile, right? Murphy does exist. One of the best examples of sort of the mutual respect and accountability between dev and ops is what happens, when fragile code happens. They have something called the handback. Right, literally it's like, sorry, ops can say, I love your puppy. It's cute, has lots of promise, but she keeps pooping on the floor, right? Here's your puppy back. Come back when she's house trained. And so I think most ops people would just die to have a handback clause, right? Because it says all our time is valuable, and for Google, right, there's a huge opportunity cost by having to support fragile code. So that's certainly one way of feedback. Another way of feedback is around monitoring. So this is John Allspaw. He's of Allspaw-Hammond fame. And so the purpose of putting up his picture is not to show him, but what's behind him. In almost every DevOps organization I've seen, there's something that looks very similar to this wall of metrics. And so they have gone on record saying they have now 250,000 production metrics running all the time, right? That span application, database, operating system, storage, networking. And what is amazing is, let's actually read that quote. Having a developer add a monitoring metric shouldn't feel like a schema change, right? So they've built this huge set of libraries, StatsD, that essentially make it possible to emit one line of code that automatically populates a new graph in production. And so basically the cultural norm they've set is that if a developer doesn't create production telemetry, right, by adding one line of code, they deserve to be shamed into writing that one piece of line of code, right? And so once they do that, now they can get all these, they can leverage Tableau, they can actually get all these wonderful monitoring tools just for free. And by the way, so that's the graph on the bottom, and by the way, every vertical bar is a deploy, right? So now we know we can actually paint, whenever we do a deploy, did it actually cause, some aberration in the metrics. So I've been watching the deploys at as many DevOps shops as I can, and so this is at Rally Software. So they're about a $100 million a year, software as a service, doing agile planning. Look at the we got the production metrics here, right? And then look at Sharon Reddy's face. He's the director of IT operations. I think someone whispered to him, the dilithium crystals are fluctuating. They're about 70% capacity, and we don't know what's wrong. And everyone is staring at these boards, right? They're trying to figure out, is it a storage issue? Is it a database issue? And so speaking as someone who came from the security monitoring space, there's nothing more heartwarming than actually having people pay attention to production telemetry, right? The biggest cause of PCI data breaches is no one actually was looking at the logs, right? And so in a DevOps shop, right, trust me, people look at the logs. So another way of feedback, right, is, and this goes against a lot of how I was trained. I think the days of long meetings deciding whether to deploy code or not based on what people put into a Word doc that in a request for change document, I think those days are probably coming to an end, right? Because how do you judge the riskiness of a change that spans 10,000 lines of code based on what someone wrote in a Word doc, right? I think the real feedback, right? So in the low trust command and control management style, every time there's a big production outage, right, the countermeasure is one more approval on the change deployment form, right, one more level of management that has to say yes, right? And I think what I've learned, and Jez Humble has convinced me utterly of this, is that that actually results in a higher likelihood of the failure happening again, right? Because we're removing the feedback from the people actually doing the work and the outcomes, right? So, what should it look like? It means that every time we have a production failure, really that should result in at least one more automated test in the continuous deployment pipeline so we can prevent it from actually happening and we can catch it before it goes into production. And if we can't prevent it, then we should actually enable quicker detection and recovery. So optimize for mean time to repair, not mean time between failures. So the outcomes is, when we have shared pain, that creates, we have defects and security issues being fixed faster than ever. Once we have figured this one deployment pipeline out, we can actually roll it out to the other projects in the project portfolio. And now all groups are coordinating and communicating better, but most importantly, everyone's getting more work done. Comments, questions, concerns? Thumbs up? Yeah.
Who has time to hold on to a feature for 6 months in a market like DC?
6 months. Who has? Can you ask that one more time?
Well, the Google slide that you showed us.
Oh.
It was 6 months, and I know on scale, like nobody's going to hold on to a feature for 6 months. So. Maybe this is answered in the future slide.
No. Actually, let me rephrase that. They deploy hundreds of times a day, but developers own the service levels and the uptime requirements. In other words, who gets paged when something goes wrong? Developers. Only after they've self-managed, self-run for 6 months, do they go through, are they eligible for the HRR, handoff readiness review? Yeah, good question. Yeah. Hey, the ex-rational guy. Just kidding. I love ClearQuest. I love ClearQuest.
Another way I've seen it implemented is developers getting a warranty period for operations,
Yeah.
where when a support ticket is opened, it's not ops or support handling the support ticket during a 6-month period or something, but the developers handling it.
Exactly.
That's another very good way of doing it, where there's no ops component in there, but Dev still takes responsibility while it's deployed.
Absolutely. In the service management ITIL terms, right, that's warranty and utility. There's a 6-month warranty, right? It doesn't even get transitioned to operations, though. It just stays in development. In fact, and I'll share with you some Netflix examples of how they do that. Any other questions? Okay. So the first way was the way of flow from left to right. The second way is feedback from right to left. And the third way is all about creating a culture of continual experimentation and learning. So I think there's 2 components to this. One is we need a culture that says it is everyone's job, just like it is to pull the andon cord, it's everyone's job to take risks, do experiments, as long as we learn from successes and failures, right? As long as we know what the global goals are, right? We have to experiment. In other words, just because we've had the same change management process or the same SDLC for the last 20 years, right, doesn't mean that it has to always be like that. The second one is understanding that repetition is a prerequisite to mastery. One of the things I'm just very fascinated by is there's so many schools of thought now that are saying, whether we're talking about learning to play a musical instrument, special forces training in the military, or training a sports team, it is always better to practice 15 minutes a day every day than it is to practice once a week for 3 hours, right? So I think the reason is because it's only through repetition that creates habits, and by changing habits, that's actually what changes outcomes. And so the reason why is that we need a culture that says it's okay and expected to keep pushing into the danger zone, right? But we also have to have the skills and habits to be able to retreat back to a place of safety when things go wrong. By the way, another interpretation of the benchmarking findings is that high performers are doing 30 times more changes, but they only have twice the change success rate. So that actually means they're doing more, they have more failures than non-high performers, right? In other words, that means there are actually a lot more deployment failures, but that's a part of, learning. So what is the DevOps kind of manifestation of this? Adrian Cockcroft. There's a gentleman here, in fact, remind me to talk about Cvent. Is there anyone from Cvent here?
I worked there a long time ago.
Yeah, interesting. There's a guy there named Paul who actually, Adrian Cockcroft worked for him, right? And he actually worked with this other guy that I'm going to mention in a second. Anyway, Adrian Cockcroft, he's a cloud architect at Netflix. he said, our goal is to do painful things more frequently. In other words, counter to all human nature, right? And so we can make it less painful in the future. And he said, even though we make life hell for developers sometimes, the reaction we get back from them is, thank you. Thank you so much, because we know that this is actually going to make deployments go more smoothly in the future. So I think the best testament of like the efficacy of this philosophy and practice is the first Amazon EC2 failure. So in April 20th, 2011, in the first global EC2 failure, every organization that went down, that relied on EC2 went down. In fact, my buddy Josh Corman again, he was giving a talk at Source Boston, and in the middle of his presentation, everyone looked at their phones and then left, right? Because they had an Ops 7.1 incident. So every organization went down except for Netflix. So for weeks, everybody was asking, what is it that Netflix is doing differently that resulted in such a different outcome? And so that's when they put out this seminal blog post that essentially revealed two things. One is they said, we can never rely on Amazon for availability. In fact, I guess that's obvious in hindsight, but they said they will never be there when we need them most. Not so obvious. The second one is the emergent philosophy. In order to survive failure, we decided that we had to fail all the time, right? And that's when they unveiled Chaos Monkey. So I mean, for those of you who aren't familiar with Chaos Monkey, I mean, this is breathtaking. It runs on every production server in the cloud, and it randomly kills processes and entire compute instances all the time in production. In other words, large-scale fault injection in production, right? And so, as you can imagine, right, by doing that a lot, right, quickly you get more resilient code, more resilient environments, and a more resilient organization. So one of the things they don't talk about, but I really wish they would, because I think it's prudent, don't run Chaos Monkey in production without running it in test first, right? So they actually run it at a far higher rate in the test environment as well as in every dev environment. So I think the patterns that we can derive from this are any place where it's possible to break things before we get to production, we should, right? Assert statements aren't just for code, it belongs in everything, right? We should be testing for the correctness and consistency of the environments, of configurations. I just want to mention this one thing about static code analysis. One of the most interesting talks I've seen in the last decade was actually from the Twitter InfoSec team. So this was the team that basically became responsible for Twitter InfoSec after the Barack Obama account got hacked, where the FTC landed them an injunction that said, thou shalt have a security program for the next 25 years. So one of the things that they realized they had to do was fix the code quality. And so they built a tool called Brakeman that essentially did static code analysis, not only whenever developers committed code, but whenever they hit save. So when you write some code and hit save, you will get an email from Brakeman saying, hey, we just noticed that there's a new cross-site vulnerability risk on line 57, right? And by the way, click here to learn how to fix it. And when you fix it and hit save, you get another email from Brakeman saying, thank you, congratulations, right? Please rate the helpfulness of our guidance on a scale of 1 to 5. And right, by doing that, they were actually able to embed themselves into daily development as well as operations. So I think the days of doing code scanning at the end of the project run by the security guys and you get like this 200-page PDF file back, right? Those days are going to be over soon. So the last practice I'm going to share with you is from Marty Kagan. I love this edict. He said, what product management needs to do is take 20% of the cycles off the table right away. They're not for product managers to use, they're for developers and ops people to work on whatever they want, right? And he said, if there's any amount of technical debt, 20% is not enough. It should be higher, like 30 or 40%. So why would anyone listen to Marty Kagan? Because he owned product management at eBay in the early 2000s, right? And he basically said the inevitable consequence of not paying down technical debt is that you will not only spend 20%, but you're going to spend 100% of your time paying down technical debt. In other words, he had this phrase, imagine what it feels like to tell all your professional peers and colleagues that you haven't shipped a new feature in 2 years, right? Because you're spending all your time on chronic site down issues, right? And so, and by the way, this gentleman at CVent, he actually not only did Adrian Kockoff work for him, but he actually worked with Marty Kagan at eBay. So I was like, wow, I really want to take him out for a drink. Anyway, so 20% paying down in technical debt, right? So the whole notion of having hack days at Facebook, 1 day out of every month, developers and operations people just pick one area to refactor. Anything problematic, anything that takes a long time, anything fragile, right? That's how we go from an environment that looks like this, that turns into this, right? If we can sort of create that collective will to pay down technical debt, refactor, improve the deployment processes, that's how we get to this. Great for availability, great for deployment flow, great for the business. By the way, just a little trivia fact. The working title of the Phoenix project was originally called When IT Fails, and we did a lot of title testing, Phoenix project was like the decisive winner, 10 to 1. We did a lot of subtitle testing, and the one that won was a novel about IT, DevOps, and helping the business win. We actually almost went to print with that title, but we changed it at the last minute to Our Business Win. We did this at TripR2 in development. We called it The Business. It's like, the business wants that. It's like, I don't know, the business says we gotta. Right? It's like, I think the business, when you talk about the business like that, I think it's indicative of like victimhood, right? It's like we become order takers where we're just doing whatever, we have ceased to object and try to change the minds of the business, right? And we're just doing whatever they say. And I think kind of the opposite of that is, very much the DevOps mindset is like, we're all part of a team that's helping our organization win in the marketplace, right? So it's not the business, it's our business. But I still catch myself saying it every once in a while. So last little factoid. Scott Cook was the founder of Intuit, and this is like one of my favorite quotes, but I gotta tell you, the first time I saw this quote, I fell out of my chair, right? This quote says, in the middle, they did 165 experiments for the TurboTax property in the peak tax filing season. And so my first reaction when I saw this was like, these guys are idiots. Like, what sort of moron would do 165 changes in, when it matters the most, right? Because the way I was trained, it was through the retail shops, right? It's like the production outage risk around the holiday shopping season was so high, we had a production freeze from October 1 to January 30th, right? So like, what sort of morons would do 165 changes? And I think the reason why is right here, is that by doing those experiments, they actually increased the conversion of the website by 50%, right? Which is astonishing. So had they waited till April 16th, it would have been too late. They would have lost a customer to the competition, maybe never to return. So it takes great ops to do this. It takes a very short lead time, right? And I think this is what really makes a critical capability that helps our organizations win. In the DevOps observability practice, there were 2 to 3 signals of performance: production artifacts and version control, automated code deploy, and environment creation processes. And there was actually one more. There was a linear relationship of how long of performance, likelihood of being a high performer, and how they answer this question. How long have you been doing DevOps? Literally, the longer they said they were doing DevOps, the greater the likelihood of being a high performer. So my interpretation of that is that focused practice matters, and it almost doesn't even matter what you do. Performance will improve as long as we're focusing on the global goals. So why do I think this is important? 2 reasons. One is that the downward spiral. This downward spiral left unchecked without practices like continuous integration, continuous delivery, and DevOps, leads to a sense of hopelessness and despair, right? It has horrendous business outcome, but I think it also has a huge human cost. I think about the days when I've woken up and my jaw is aching from clenching it and grinding it all night, because those are the days when I was having to fix the mess of something on a daily basis made by decisions upstream by people who didn't know what they're doing, right? I think that creates a sense of preordained failure and inability to actually change outcomes. And like I said, that's one of the worst things we can actually do to another human being. The second aspect is economic. Fellow co-author and I, Mike Orzen, we did a calculation that our goal was to try to figure out how much business value is there on the table if we could just have the amount of waste in the IT value stream and redeploy it in a way where we could get 5 times the value. The number we came up with was $2.6 trillion per year. That is such a huge number. That is more than the entire economic output of Germany. So, think about like if we could inject $2.6 trillion into the economy each year, what would that do to the number of fundable projects? What would that do to standards of living, productivity? But in my mind, the way I think about this number is, what does this do to the world that my 5-year-old and my 2, 3-year-olds are going to inherit? Right? $2.6 trillion times 2 decades, right, will make a material difference in the levels of health, wealth, and prosperity. And these are the things that actually make world peace, more possible. So I think that is a problem we're solving. So if I could wave a magic wand, I'm hoping that everyone will Recognize DevOps patterns when you see them. Yeah, I'm positive you've seen these before, right? Especially the ones that were on the first wave, but I'm guessing that you've probably seen aspects of the second and third way as well. I'm hoping that you will find those people and say, oh my gosh, we are fellow travelers, right? And have the ability to actually work on a DevOps project together where Dev, Ops, Test, InfoSec are all working together as a team and getting outcomes that we've never seen before. One of my favorite quotes in the Phoenix Project, testimonials, came from a guy named Jeremiah Shirk. He leads the DevOps initiative at Kansas State University, and he said, there are 3 types of books. One is a novel that you give to a friend because you think they'll enjoy it. The second is a book that you give to a work colleague because you think it might help expose a shared problem that might open up the opportunity to have a shared goal to work on together, especially if it's between 2 different silos. And the third one is a book that you give to your boss because it plants the seeds of a big, dangerous idea like DevOps. And I got to tell you, it delights me to no end that he said, the Phoenix Project is, all 3. Our goal is to positively influence the lives of 1 million IT professionals by the year 2017. And we chose the story format for the Phoenix Project very deliberately. Studies have shown over and over again that the most effective mode of persuasion is storytelling. And so when we can tell a story that actually elicits a reaction like, holy cow, that's us, right? And that's probably one of the best ways to actually create this tribe that doesn't exist right now. Or, so we actually, to advance that end, we've made the first half of the book free. So if you want the first 170 pages, you go to the itrevolution.com website, you just Google for free Phoenix Project excerpt, and you'll get a PDF file back. So spread that around. I found that this is an exceptionally effective vehicle to find fellow travelers, right? The people who actually come back and say, thank you so much, right? We are Parts Unlimited, right? I'm hoping that those become the basis of the coalition that you build to put your own DevOps practice into place. The slides are available at slideshare.net, Realgene Kim, and there's one project I want to mention. 3 projects. Can I go 3 more minutes?
Yeah,
Sorry, I'm a little bit.
Yeah. 5 minutes.
5 minutes. All right. There's 4 projects I'm working on right now that, if you're interested, email me with just a 1-line subject. One of the biggest impediments of DevOps, I believe, is going to be the auditors. Like, nothing freaks out auditors more than seeing developers doing their own deploys, right? That goes against every sort of thing that we've been trained not to let happen, right? It breaks change management, it breaks separation of duty. On the other hand, right, we know that, so how do you diminish that? So our goal is to build a toolkit that basically shows the auditors that we understand the business objectives, the risks, and we have a control environment that can prevent, detect, and correct. And so one of the people who's helping with that is James DeLucia. He's a senior manager at Ernst & Young, the audit firm of record for Google, Amazon, Rackspace, and so forth. So if you're interested in that, just email me a note and just put audit on there. The second one is, let's call it Enterprise DevOps Case Studies. And by the way, thank you so much for Dave Ashton and Mike McGarr for sharing theirs. Watching what Blackboard Learn has done, I think blew my mind. And you should ask Dave and Mike about their transformation story. But how do you adopt DevOps in something where you're not in a green field? How do you do it for something that doesn't look like a lamp stack? How do you do it for SAP and .NET environments? By the way, one of the best presentations I've seen lately is the enterprise architect at SAP describing how they did continuous delivery for SAP at SAP, right? They took it down from 1-year deploys to 2 deploys a week. If you can do it for SAP, trust me, we can do it for anything, right? So if you're interested in that, write down Enterprise DevOps. And if you're interested in reviewing early drafts of the DevOps cookbook that I'm working on with many smart people, including Jez Humble, please let me know. Just put cookbook down, and on the condition that you don't make fun of us for being so late. It's supposed to come out last year. At any rate, thank you so much, Mike. I really appreciate the opportunity to present.